Hi there, my name is Mitch Karlabidis, and in this video we will continue my series of videos which are dedicated, let's say, to graph transformations. So far we had an introductory video on transformations on which we learned hopefully how to determine a graph transformation based on whether the change occurs in the output or in the input, and whether we have an addition, subtraction, multiplication, or division. Then, on the second video, we saw a special type of transformation, the one of translations. And now we will continue with graph dilations. So let's put a proper title here, graph dilations, and let's start. We are in the third case. The first two were about translations. And in the third case, we will explain first what happens when we transform f of x into k times f of x. First of all, here we do see that the change occurs in the output, in the entire f of x. So it has to be a vertical one. And with regards to that change, the change is a multiplication which directly translates to a dilation. So this time we have a vertical dilation. Vertical dilation means that the graph will change its shape. And this means that it will either shrink or compress, if you prefer that, or it will stretch. Whatever happens, whether it's a shrink or a stretch, the factor in this case is k. And by factor, we mean the number with which we will multiply so that the graph dilates. More precisely, if k is greater than 1, we say that it's a vertical stretch by factor k. If k is greater than 0 but less than 1, we would describe that as a vertical shrink. For example, from f of x, if we transform to 2f of x, we can describe this as a vertical dilation of factor 2. And if we want to be more precise, we can describe that as a vertical stretch by factor 2. In a second example, if we go from f of x to, let's say, 0.6 f of x, this describes as well as a vertical dilation of factor 0.6. But once again, if we want to be more precise, we would call that a vertical shrink by factor of 0.6. We have been saying in the previous video that every way we use to describe a transformation can be also seen as a set of directions, as a set of instructions on what should be done in a random point and how we can find the new coordinates at which that point will transform. For instance, vertical dilation by factor k. Let's try to translate that. First of all, the word vertical has to do with the y coordinate. The word dilate can be translated as multiplication, and the word factor is the number with which we multiply. Number with which we multiply. So this means that when we refer to a vertical dilation of factor k, practically speaking, we mean the same thing as multiply the y-coordinate of the point by k, which means that under this transformation, the random point with coordinates xy will move to x, ky. For example, the f of x moving to 3f of x can be described as a vertical dilation of factor 3, which, as per instructions, can also mean that we should multiply, that stands for the dilation, the y, that has to do with the vertical, by 3. So the random point xy will turn to x, 3y, which means that if we had, let's say, the point with coordinates 1 and 6, that would have moved at 1.18. Let's see now the fourth case, which still is a dilation, but this time it should be a horizontal one. F of x moving to f of kx. How did I recognize that it is a dilation? I recognized the dilation by the fact that we had a multiplication. How did I recognize the horizontal effect of that? The horizontal had to do with the change occurring in the input, just inside the bracket. Now, you should remember the one we keep saying. Ahat. All horizontals are trolling us. And let's see what we mean by that. First of all, the trolling part 1 has to do with the fact that the factor is not k, is not the number we see directly, but it's 1 over k. And secondly, if k is greater than 1, then although we can see that we multiply by something which is greater than 1, by 1, so we would expect that to grow, we actually multiply that by 1/2, by 1 over that, by its reciprocal. So we multiply that by something which is less than 1, which means that eventually, instead of stretching, it will shrink. So we have a shrink. If k is between 0 and 1, we expect that to stretch. Let's see some examples. From f of x, we move to f of 2x. This can be described as a horizontal dilation of factor, not 2, but we've said it's reciprocal, by factor of 1 over 2. F of x moving to f of 0.6x is a horizontal dilation of factor not 0.6, never what we see, but it's reciprocal, 0.6. F of x moving to f of x over 3, it's again a horizontal dilation of factor not 1/3, and that's because x over 3 can also be seen as 1/3 x. So the factor will not be the 1/3, but it will rather be its reciprocal of factor 3 over 1, which is equal to 3. And again, any description of a transformation can still act as a series of instructions. Horizontal dilation. Horizontal dilation by factor k means multiply, and that has to do with the dilation part. Multiply the x, and that has to do with the horizontal, sorry about that, about the horizontal part, the x, by that factor, by k, by, let's put that here, by k. For instance, from f of x, we move to f of 3x. This describes as horizontal dilation of factor 1/3. This means multiply the x by 1/3. So the random point with coordinates x, y will move at 1/3 x, y, which also means that, for instance, if we had the point with coordinates 10, 12, that would have moved at 1/3 times 10, 12. A final example, f of x moving to f of 1/2 x. This again can be described as a horizontal dilation of factor, not the number we see directly, not 1/2, but rather its reciprocal. And by reciprocal, we mean the flipped version. The flipped version of 1/2 is obviously the 2.1. So here we would get a horizontal dilation of factor 2/1, which describes as per instructions to the following. Multiply, and that has to do with the dilation, dx, and that has to do with just the horizontal, multiply dx by 2/1. So the random point with coordinates x, y would have moved to 2x, y. That's all. Remember that as in translations, the horizontals here as well lie. They are trolling us. Remember that the horizontal, the factor is always the number with which we multiply. In a vertical, we can see directly the number with which we multiply, but in the horizontal, it's reciprocal. And remember that vertical means the change occurred in the output. Horizontal means the change occurred in the input. That's all for now. We will have more videos on transformation. I hope you like that. And in case you have any issues, any questions, please feel free to leave your comment, your question below the video. As always, thank you for your time.